Welcome. This is the beginning of chapter 3. We're going to do section 3.1, and it's just an intro to probability. The whole chapter is going to be on probability. I'm going to start with just talking about a little fractions and decimals. This is going to be a review for a lot of you, but some of you haven't taken math in a while, so I want to make sure that we're on the same page. There's two ways to write a probability. One is in fraction form, say for example 2 out of 5, and one is in decimal form, say 0.71. These are not equivalent. These are just examples, decimals or fractions. The way that you change a fraction into a decimal, you won't have to go the other direction. You won't have to go decimal to fraction. The way you change a fraction to a decimal is you just do what that says. That line means divide. So you just do top to bottom. 2 divided by 5 on your calculator equals, and then it'll give you a decimal. So that's how you're going to change a fraction into a decimal. Sometimes the decimal will come out like my example here, 0.71, and sometimes it'll come out as a really long decimal. So I want to talk to you about how to round. And this will be important for your online homework. On your written tests, I don't care so much. You can decide how and where to round, but on your homework, it'll be specific and it'll mark you off if you round incorrectly. So I want to make sure that you know how to do that. So let's say that you change your fraction, you do your 2 divided by 5 or whatever your fraction is, and it kicks out a decimal. Let's say it looks like this. Okay, the first thing that you need to know is what each position is named. So if we have 123, most of you guys know this is the ones place, this is the tens place, and this is the hundreds place. The decimals are the same going the other way, except we skip the 1 and we start with the 10 and we put a TH on the end of everything. So this first position right here is called the tenths. Oops, that's not right. Spelling. Tenths. So it's not 10, it's tenths. And then the second is the hundredths. And then the third is the thousandths. I don't know if I'm spelling all these right, but you get the idea. So mostly we're just going to operate in like tenths, hundredths. I think some of your homework might say thousandths, but the directions will say like round to the hundredths place. That means that wants 2 decimals, two places past the decimal. Okay, now once you know what everything is, here's how you round. Let's say that I want to round to the tenths place. So I locate that position here. That's my tenths place. And then I'm going to put a line after it. This is where I'm going to cut it off. So that what that means if I say rounded the tenths is I want one number past the decimal place. And then there's 2 options. You're going to look at the number right after the line that you drew. So that's a 1. If this is 1 to 4, then you keep the 2. If it's 5 to 9, you round up to 3. That's the rule, and that's the rule for always, right? You look to the number to the right. If it's 1 to 4, you keep the previous one. If it's 5 to 9, you round it up. So in this case, a tenths decimal would be 0.2. Now, let's say that I ask you to go to the hundredth spot. Now I'm going to go 2 spots because that's my hundredth space. I'm going to draw my line after the place I want, and I'm looking at the number after the line, which is a 7. That's between 5 and 9, so I'm going to round the previous number up 1. So it's not going to be 0.21, it's going to be 0.22. All right? So that's how rounding works. You can practice that. If you need help, let me know. Next thing that we need to do is talk about how to build probability. So most of the time we're going to build probability in fraction form. Here's your fraction, here's your line in the middle. On the top is the number of ways a thing can happen. And this bottom number is going to be the total options for the situation. All right, so let's do a really simple example. Let's say I'm going to roll a 6-sided die. So it's just one die, and each side, there's 6 sides, and each side has a number, 1, 2, 3, 4, 5, 6. So if I'm going to build a probability, I want to know what's the probability, say, of rolling a 6. So this bottom numbers, actually, let me do this. Let's do the probability of rolling a 5. Now, the notation for this, for any kind of probability, is P and then parentheses, and then you put in that parentheses what you want. So like I might write this as P probability of rolling a 5. So I'm going to build a fraction, and I'm going to, on the bottom, put how many options are there in this situation. How many options could I get if I roll a side? And the answer is 1, 2, 3, 4, 5, 6. I could get 6 options. And then how many ways, number of ways this thing can happen. How many 5s are there on the die? And the answer is 1. Now, it's not a value of 5. It's how many 5s are there. That's what the top number is. So this probability is going to be 1 out of 6. And then you can divide that out if you want a decimal, okay? Some of your homework problems will allow you to do either or. Let's just do, I'm not going to divide everything out, but let's just do this one. So let's go 1 divided by 6. So let's look at this number. I've got 0.16666. So where do we want to round to? Let's say we want to round to the hundredths place. So I'm going to go, there's 2 decimal places. That's my 1 and 6. I'm going to draw a line after that 6. And the number after that is a 6, which is more than 5. So that means I'm going to round this previous number up 1, up to a 7. So this is going to be 0.17 if I want to go to the hundredths place. If I want to go to the tenths place, it's going to be 0.2. All right. So that's how you build your probability. Now let's do something that's a little bit more interesting or different. Here's some cards. Let's just look at these for now. Let's say I want to, all these cards have numbers, and they also have colors associated with them. So first of all, vocab word, sample space. The sample space is your bottom number. It's how many options are there? What are the options? Like I would say my sample space here is all the cards. And I could list them while they're listed out for you right there. So this whole thing that you see, that whole list is called your sample space. And it's going to be represented by the number on the bottom of your probability. So no matter what I'm asking you for in this section, whatever probability I want here, the bottom number is going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24, so it's going to be 24 because there's 24 cards. Now, let's do some examples. What if I want to know what's the probability that I'm going to randomly draw a yellow? All right, well, how many yellows are there? That's going to be your top number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? And you can turn that into a decimal, divide it out. I'm not going to divide these out for you anymore. Hopefully you understand how to do that. We're just going to work on building them. Okay. What's the probability that I draw a 4? Again, 24 is not changing because there's still 24 cards in the sample space. But how many 4s are there? Well, there's 1, 2, 3, 4. All right. I think that's right. I think that I just see 4. Yep. Okay. So I've got 1, 2, 3, 4. That's where that 4 is coming from. All right. Let's scroll down here. We've got some different cards with animals on them. What's the probability that I'm going to draw a 1? See if you can pause the video and write it down. I'm going to start by counting my sample space. I've got 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That's going to be 24. And then how many 1s do I have? I've got 1, 2, 3, 4. So I'm 4 out of 24. Oh, there we go. All right. I think that's good enough. Now, what would be 100% probability? You'd have 100% chance of getting, if I'm going to deal you one of these cards, well, that would be like any card, any fish, any cat, any bird, any dog. So if those were all options, my probability would be 24 out of 24. This is the max you can have for a probability, right? If I'm going to deal you a card and there's 24 of them, the maximum probability is a 24 out of 24 chance. This divides out to 1. So as a decimal, 1 is the max for probability. Everything else is going to be less than 1. It's going to be a decimal with no whole numbers. So 4 out of 24, for example, is going to be like point something, not a whole 1. Now, we talked about, let's talk about how to change a decimal to a percentage now. So let's go back up here to our decimal example. Let's say we have 17.17. That's our probability. If I want that as a percentage, what I do is I take this decimal place and I'm going to move it 2 places to the right. Decimal to percentage moves 2 to the right. Percentage to decimal moves 2 to the left. So this would be a 17%. If you come up here, let's say I want to take this value and turn it into a percent. I'm going to take this decimal and go 1, 2 to the right. So this is going to be a 22%. Now, what happens on this one? 0.2. If I want to move that decimal 2 to the right, I've got to go 1, 2, which means I've got to put a 0 to hold that place. So that's going to be a 20%. All right, now let's go back to our 1 situation. This is our max probability. As a percent, the decimal place on 1 is right here. So if I want to turn that into a percent, I go 2 to the right. So I'm going 1, 2. I've got to add zeros to hold that place. So this is going to be a 100%. Now think about this. If you have a 100% chance of getting of something happening, doesn't that make sense that that's 24 out of 24? Any of the cards works, that's 100%. Okay, but you can't ever have more than 100%. So, like, when we say, I want you to give 110%, it's a figure of speech. But technically, like, you can't give 110%. You can't give more than 100%. So this is our max. So let's take a look at a bunch of kind of numbers. Let's go 1.27. Let's go 0.27. Let's go 57%. Let's go 115%. Let's go 2 out of 12 and 15 out of 4. Okay, the question is, which of these can be a probability? Well, let's start here. This one, that's 1.27. Now, change that into a percent. you move the decimal 2 to the right. That's 127%. That's more than 100. Notice that you have a whole number and a decimal. This is not a probability. It cannot be a probability because you cannot ever go over 1. Here, 0.27. There's no whole number in front of that 0.27. So that means that this can be a probability. Move the decimal 2 to the right, you get a 27%. This can be a percentage. This one, 57%, that's good. Yes. It's less than 100. Here, more than 100. No. Now let's talk fractions. 2 out of 12. If you're not sure, divide it out. Okay? 2 divided by 12. I think it's 0.1 something. Let's check. 2. Oh, I think it's what I just did. 2 divided by 12. It's 0.17. Oh my goodness. 0.17. So that's 17%. There's no whole number in front of the decimal. This, though, what's that? This divides out. 15 divided by 4 ends up being 3.75. Change that into a percentage. Move the decimal 2 to the right. That's 375%. This is not a probability. Okay, so I just want you to know that when you're doing the math in this section and it's asking for a probability, if you get a number over 100%, you did something wrong. That's a huge check. All right, now generically we can write notation for probability as this. So I could just say P of it. We say this P of E. The parentheses mean of. It's a different of than sometimes in math of means times. In this case, it doesn't. It means it's composition. That's not necessary for you to know. But this is the probability of an E stands for an event. So what this means is this is a general probability. It's not specified what it is. So in your homework, you're going to see something like this. Now, I want to talk about this mark right here. That I didn't write that very well. This is like a little hash mark on the side. What that means is the complement. And the complement of an event is the opposite. All right, so let's say the probability that it's going to rain tomorrow is 2 out of 12, let's say. The complement of that would be the probability that it doesn't rain. It's the opposite of that. So probability of no rain. And what this little formula says is that, hey, if you have an event and the opposite of the event, it should add up to 1, which is, again, 100%. So if I have a 2 out of 12 option of rain, then I've got a 10 out of 12 option of no rain. Now, add those up. I know adding fractions, might have forgotten how to do that if you need to use a calculator, but basically when the bottoms are the same, you just add the tops. So what's 10 plus 2? 10 plus 2 is 12 out of 12. So that's 100%. See how those add up to be? So how did I get this 10? I took the sample space, the total 12, and I subtracted 2 from it. And that gives me the opposite of an event. Okay? So you can play around with those formulas. You'll see those in your homework. Also, I want to talk to you about what an unusual... Oh my gosh. Hold on. I can't spell. Sorry. An unusual event That's kind of a funny word. It actually has a very specific math meaning. It's like mathematically or statistically improbable is what unusual means. And what we say is an event is unusual if the probability is less than 0.05. So when you divide out that fraction, when you figure out what that is, divide that out. The decimal that you get, you're comparing to 0.05. And if it's less than that, it's unusual. And if not, then it's not. So let's take our decimal 0.12. Let's say that you have a 2 out of 12 chance of something happening. You divide that out, you get 0.12. We're going to compare that to 0.05. The way that you compare decimals is you start at the decimal place and compare the first number. And whichever one is bigger there is the bigger number. If they're the same, you go to the next one, and whichever one's bigger is bigger, and you keep doing that until you figure out which one's bigger. So this guy is bigger, so it's not less than 0.05, so that means that 0.12 is not unusual. All right, that'll get you started on most of the problems. Now, vocab. There's two types of probability. There's an experimental probability and a theoretical probability. Experimental is what actually happens, and theoretically is what is mathematically, or we'll say what mathematically should happen. So let's do an example. Let's go back to the rolling the die. If I say, what's the probability of getting a 4? You would say, okay, the sample space is 6. So because there's 6 options on the die. How many 4s are there? There's 1. So my probability of rolling a 4 is 1/6. That is a theoretical probability. I computed it mathematically. Now, what this means is that every 6 times I roll the die, I should get a 4. So what the experimental does is I'm going to give you a die and I'm going to have you roll it 6 times. And then you record what you get. Now, if you've played a game before, you know that it's very possible, you're like 1 roll away from home and all you need is a 4 and you're sitting there forever, right? And you keep rolling and you're not getting the 4. So it's not true that I always get a 4 every 6 rolls. It just doesn't work that way because it's random. But the theoretical says it should be close to that. All right, so like maybe you roll a 1, a 2, a 2, a 5, a 4, and a 4. So if these are your rolls, what's the probability? What is your experimental probability? Well, it's 2 out of 6 because you rolled 2 4s out of your sample space of 6. It's different than your theoretical probability, but this takes us to the law of large numbers. And this is an activity that I usually do when I have an in-person statistics class. I'll we just hand out a ton of dice and everybody rolls a bunch of rolls and records all of them. And then we add up all the numbers and put it on the board. And what happens is the more times you roll the die, the larger your sample space, that's where that large law of large numbers comes, the more your experimental and your theoretical probability will align. So in this situation, These guys are pretty far off. 1 out of 6 is 0.12. 2 out of 6 is 0.33. That's a really big difference. 12% or 33%. That's because I only rolled the die 6 times. But let's say I rolled it 100 times and figured out how many 4s out of 100. The more I roll, the closer my experimental probability will get to 0.12. So the law of large numbers says is the larger your sample space, the more times you run the experiment, the closer the experimental probability comes to the theoretical. All right, so in essence, what this is saying is if you want to be accurate when you're running an experiment, you need to sample a lot of people, do the experiment a lot of times. Now, why is this important? If you're going into psychology, if you're going into healthcare, if you're going into anything where you're going to run an experiment, and for sure my STEM people, but most of you are probably not STEM. So anything like wildlife related, where you're going to be counting wildlife, tracking anything in nature, that kind of stuff, you're going to be running experiments. And what the law of large numbers says is you can't run an experiment 3 times and expect to understand what's going on. What you have to do is sample a large number of people. So, for example, let's say you're a pharmaceutical company and you're testing a drug. You don't want to test it on 3 people. You want to test it on 300 people or 3,000 people. The more people you test on, the more reliable your outcome becomes, because you could just randomly select somebody that is not really typical, and then that throws off the results of your experiment. So that's why this law of large numbers is important. All right, now last topic on this, I want to talk to you about how to build the bottom of your fraction. Okay, so we're not talking probability, we're talking sample space here. Sample space, how to build the bottom of the fraction. Because sometimes it's not as easy as just counting stuff up. So like in the card situation, I was able to just count the cards. There's 24. It's not always that easy. So say, for example, say you have a 1, 2, 3-digit code, okay? And you're trying to break into your, actually, let's make it 4, because I think that's what a cell phone usually is. All right, so you got to break into your friend's cell phone, and you don't know what the code is. What's the probability that you're going to guess the code? That's the question, right? So what's the probability that you're going to guess the code? So, well, the bottom number is the sample space. Let's pause on that because I don't know what that is. How many options are there for the code? There's only one right code, right? So this is going to be 1 out of how many options are there? But this is the question mark, and that's what this counting principle tells us. When you have separate events like this, like you have a code and you have to type in 1, 2, 3, 4 different numbers like that, the way that you figure out how many options there are is you simply multiply the options in each scenario. So let's go for the first digit. How many options are there? Now be careful with this. There's not 9, there's 10, because I can have 0, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 options for what to type here. And then my next number that I'm going to type, I've also got 10 options. My next number is 10 and my next number is 10. And the counting principle says multiply them all together, and that's how many options there are. So this ends up being 10,000 when you multiply it together. So what's the probability of guessing the code? Well, it's 1 out of 10,000. That is unusual. That is less than 0.05 if you divide that out. Okay, so that's how what you're going to practice is it's just going to say how many options. It's not asking for probability. Remember, we're just counting how many options are in the denominator of this fraction. Here's another example. I have 3 jackets. I have 2 pairs of pants. And I have 5 shirts. How many outfits do I have? So you just go by event. First, I've got to pick a jacket. There's 3 options. Then I've got to pick a pair of pants. There's 2. And then shirts, there's 5. Multiply them all together. This is going to be 30 outfits when you multiply those together. And then that is your sample space. Now, also, I could write out all my options, right? Like jacket 1, pant 1, and shirt 1, or jacket 1, pant 2, shirt 1, jacket 1, pant 1, shirt 2. You get what I'm doing? Like all the different combinations. If I write all of those combinations out, there are 30 of them. So this is a quick way that it tells you without having to write them all out how many there are. We could do stuff like this. What if I have a code and it's 3 digits and the first number has to be greater than 5. The second number has to be even, and the last number has to be 9. So now there's rules on it, okay? You're still just counting up how many. So how many digits are greater than 5? Well, greater than means not including 5. So I've got 6, 7, 8, and 9. So there's 4 possibilities here. Even numbers are 0, 2, 4, 6, 8. So I've got 1, 2, 3, 4, 5 options there. And then how many 9s are there? There's just 1, right? It's really tempting to write 9 right here. So be careful. Remember, you're asking with probability how many of them are there. There's only 1 9. So there are 5 times 4 times 1, which is 20 options for this code. And that's the counting principle. So be careful with the directions. Am I asking for a probability? Then you're building your fraction. Am I asking how many ways something can happen? Then you're just multiplying your options. All right, we'll see you for section 3.2. We'll talk about some more complicated probability in the next section.